Hi everyone, today we're looking at Unit 5, Lesson 4, Quadratic Word Problems. So the word problems we're going to look at today, we're going to read through them, we're going to see if maybe drawing a sketch will help, but the ultimate goal is to set up a quadratic equation that we can work to find the solutions for. So just some tips as we work through these word problems today. We're going to, draw a picture. And then the goal is to set up a quadratic equation. Now sometimes when we set up our equation, it might not necessarily look like a quadratic, but once we expand and simplify it, we should get it into a quadratic in standard form generally. So let's take a look at this first one. It says a rectangle has dimensions of 3x plus 1 and 2x minus 5. Its area is 1,150 centimeters squared. What are the dimensions? Okay, so let's start by drawing a picture of this rectangle. We'll see if the information they've given us we can use to kind of piece together what's going on. So it says that the length is 3x plus 1, or it says one of the dimensions. We'll call it the length. And it says that the width is 2x minus 5. Okay. It also tells us that our area equals 1,150 centimeters squared. Well, we have to think about our previous knowledge about area, and we know that area equals length times width. So we can plug in what we know for all of these variables. We know the area is 1150, we know that our length is 3x plus 1, and our width is 2x minus 5. So when we have a binomial times a binomial, if we want to expand and simplify this, we know we should FOIL it. So if we FOIL, we'll get 6x squared minus 15x plus 2x minus 5. Okay, I'm going to simplify and bring everything over to one side. So I'm going to bring that 1150 over to the other side. So when I do that, I'm going to get 6x squared, and then minus 15x plus 2x is a minus 13x. And minus 5, and then minus 1150 is going to be a minus 1155. Okay, so when we look at this, we have to try to figure out how can we solve this. So we can solve by either factoring or that quadratic formula. Okay, when we have numbers as big as this, just go ahead and use the quadratic formula because it will take a long time to figure out, could this factor? This number is like in the thousands. I'm not sure what numbers multiply to it. So when you have a big number, just use the quadratic formula. Okay. So we're going to plug into x equals, and then we're going to have a negative 13, that's our b, plus or minus the square root of b squared. So that's going to be negative 13 squared minus 4 times my a value of 6 times my c value of 1155. Remember, you can't plug into this quadratic formula until it's in standard form. All of that's going to be over 2 times 6. So if I simplify everything here, I'm going to end up with x equals a negative 13 is a positive 13, plus or minus, everything under that square root, if you punch that into your calculator, you should get 27,889 all over 12. Okay, so that's going to split into my two solutions where I'll have x equals 13 plus the square root of 27,889 over 12. And I'll have x equals 13 minus all of that. So try to squeeze this in. So for the first one, that's going to simplify to x equals 15 or x equals negative 12.8. Well, we can't have a negative length or width of a rectangle, so we'll reject this. Okay, so we're only working with that one solution of x equals 15. So once we have our x equals 15, we'll come over here. I'm just going to label this. So we did 1. Okay, we plugged into our quadratic formula 2. And over here we'll do 3. So when we plug in to our length and width, we'll plug into our length first. Our length will equal 3 times 15 plus 1. So 3 times 15 is 45, plus 1 is 46. And we'll plug into our width of 2 times 15 minus 5. So our width will equal, oh, I wrote minus 15 minus 5. So 2 times 15 is 30. 30 minus 5 is 25. So we can say, therefore, the dimensions are 25 by 46 centimeters. Okay? Let's take a look at the next example. So it says a rectangular garden measures 40 meters by 20 meters. It is surrounded by a walkway of uniform width. So we're going to just highlight uniform width. We'll come back to that term in a minute. So that the combined area of the garden and the walkway is twice the area of just the garden. So let's remember that as well. The combined area, so when we think combined, we should think total, of the garden and the walkway is twice the area of just the garden. So we'll start by drawing a picture again. So we have a rectangular garden. Okay, and the rectangular garden is 40 meters wide and 20 meters long. It says it is surrounded by a uniformed walkway. So that uniformed walkway, when we hear uniform, we should be thinking, okay, it's the same width of a walkway all the way around. I'm going to try to draw this walkway so that it looks like it's the same width all the way around. See if we can erase some of that. Okay, so there's our drawing. So if we have a walkway that's the same width all the way around, we don't know what that width is, but we can represent that. This is our walkway. So let's let W represent the width of the walkway. Okay, so that means the width, the distance from here to here is going to be W. The distance from here to here is going to be W. From here to here, also W, and from here to here, okay, is going to be W. So all the way around, our width is going to be W. So it says that determine the width of the walkway to the nearest tenth of a meter. So we have to figure out what is W, but it gives us some more information. It says that the combined area of the garden and the walkway is going to be twice the area of the garden. Well, let's figure out what the area of just the garden is by right now. So we know area, and I'm going to write like a little subscript for garden. So the area of our garden is going to be 20 by 40, which will equal 800 meters squared. So they're saying the combined area of the walkway and the garden is going to be twice that. So we can say times 2, that's going to be 1,600 meters squared. Okay, and that's going to represent the area of both garden and the walkway. Right? This is the area of both of them is twice the area of just the garden. So if we have that information, we should be able to figure out, okay, area equals length times width. Well, I know the area is going to equal 1,600, but what's my length going to be? What's my width going to be? So I come back to my drawing here, and if we try to represent I'm going to just pick a different color. If we try to represent what our width will be, so from here to here, okay, we know that it's 20 meters, but then we also have this uniform walkway that's W and that's W. So we have to add those two W's to the 20 meters. So we could say that this is 20 plus 2W, right? Because we have W here and we have a W here. So it's 20 plus 2W. If we look across for the length, we should see something similar happening for this. So again, we know that the length is 40, but then we have this walkway that's W here and a W here. So again, we're going to have 40 plus 2W for that side of my rectangle. So our area is going to equal 40 plus 2W times 20 plus 2W. Okay, now that we've created an equation, we want to expand and simplify so that we can eventually get it to standard form and we can find our solutions. So if we were to expand this, we'd have 1600 equals, and then as we FOIL it, we're going to get 800, and then plus 80W plus 40W plus 4W squared. I'm going to do a little bit of rewriting so that we have everything in the standard form we're used to seeing it. And we'll also move over that 1600. So let's bring our 4W squared forward. And then we will also combine our 80W and 40W is going to be 120W. And then we'll have plus 800, and we're moving that 1600 over by subtracting it. So we'll have 4W squared plus 120W minus 800. Okay, so now we've created an equation in standard form which we can solve. It looks like we have some big numbers again to work with, but before we deal with these big numbers, hopefully we can recognize that we can at least common factor something out so the numbers we're working with are a little smaller. So let's start by common factoring out a 4. We take out a 4, we'll be left with W squared plus 30W minus 200. Now those numbers are still quite big. We can try to solve by factoring it and see if we can come up with an appropriate pair. But the number is quite big. So let's first try to... So if we were trying factoring, we'd have to look at our factoring pairs. So SPF tells me that I have to sum to 30 and multiply to 200. Well, if I think about my factoring pairs for 200, I have 1 times 200. I have 2 times 100. 4 times 50. 5 times 40. We also have 8 times 25 and 10 times 20. So if we think about, is there a combination that would work here, we need to have a negative 200, which tells me one of the numbers has to be negative. So 10 and 20 look like maybe it would work, but if one has to be positive and one has to be negative, then that's not going to add up to a positive 30. So it looks like it's not factorable. No match. Okay, so if we can't do this, then we're back to using the quadratic formula. Okay, so we'll use our quadratic formula. And remember, our quadratic formula is x equals. Well, in this case, we're dealing with w. So we're going to have w equals. It'll be a negative, and then if we want to identify, we have a, b, and c. So we have a negative 30 plus or minus the square root of b squared, which is 30, minus 4 times my a value, which is 1, and my c value, which is 200, negative 200. All of that is over 2 times a. So if we simplify, we're going to have a negative 30 plus or minus the square root This will simplify to 1700 all over 2. And then if we were to do the plus version and the minus version using the quadratic formula, we would have that W equals 5.6 and W equals a negative 35.6. So we can reject that negative, say it's not possible, or write reject, because we can't have a negative side of our rectangle or a negative side of our garden. So we can say, therefore, the width of the walkway is 5.6 meters. Okay, we'll take a look at one more word problem for today. Okay, so it says a right triangle has a perimeter of 350 centimeters. The hypotenuse is 150 centimeters. What are the length of the other two sides? So we'll highlight some of that key information. And then of course we'll start by drawing a picture. So we have a triangle. It's a right triangle. We'll draw that it's a right triangle. It says that the perimeter is going to be 350. So if we think about the sides as A, B, and C, well, we know that perimeter is going to equal A plus B plus C, right? It's the distance around. And it says our perimeter is actually 350. So that's going to equal A plus B plus C. And then we don't have much other information other than it saying that the hypotenuse is 150. And remember, our hypotenuse, if we think back to Pythagorean theorem, our hypotenuse is always going to be the side opposite my right angle. So this is our hypotenuse. So we can say that C equals 150. So we're going to plug that in to the perimeter equation we already have. So we'll have 350 equals A plus B plus 150. Okay, from there we can start to try to isolate, but we do have two variables. So I'm going to at least bring over the 150 by subtracting it. And we'll have that equals A plus B. So 200 equals A plus B. So I have that. But now I'm kind of stuck because I have A and I have B. And I have to think about what else can I do now to find A or B. I don't know how to work with or solve for two variables at one time, except for we did learn how to solve for two variables when we used the process of substitution or elimination. So if we have this one equation, let's say that this is our equation 1, is there another equation we can use for this scenario that might help us to sub in or eliminate one of the variables? Okay, so another equation we know when we're dealing with right triangles in particular is we know if we have a right-angled triangle, then we can use Pythagorean theorem to find an unknown side. Okay, so Pythagorean theorem is a squared plus b squared equals c squared. So if we think about, well, do we have any of this information, A, B, or C? We do have C, right? That would be 150 squared. So we'd have A squared plus B squared equals 22,500. So if we have equation 1 and now we've created an equation 2, we can use those two equations to solve for one of the variables, A or B. So let's maybe rearrange one in order to substitute it in. So I'm going to start by stacking my two equations over here. So we have equation 1 and we have equation 2. So I'm going to rearrange equation 1 for A. So equation 1 will now be 200 minus B equals A. Now I've isolated A, right? So I can substitute that equation in for A into the other equation. So let's sub equation 1 into equation 2. So anywhere I see A in equation 2, I'm going to substitute 200 minus B. So 200 minus B squared plus B squared equals 22,500. So now we can solve for B because we have just B in this equation and then work to find A. So if I have 200 minus B, that's really saying 200 minus B times 200 minus B plus B squared. So if I FOIL, we're going to get 40,000 minus 200B minus 200B. And then B times B is B squared. Okay, so I'm going to bring my B squareds to the front of the equation because we're used to putting those at the front in standard form. So B squared plus B squared is 2B squared. Negative 200 minus 200 is a minus 400B. And then we have plus 40,000. And I'll subtract that 22,500 from the other side as well. And then I'll just combine those constants at the end. So we'll have 2B squared minus 400B plus 17,500. Now, even though we have some big numbers, we do have a standard form quadratic. So we could jump right into the quadratic formula. We're going to do that, but first, again, we could common factor something out so that we're working with smaller numbers. So let's common factor out a 2. And then we'll have B squared minus 200B plus, 17,500 divided by 2 is going to be 8,750. So now that we have that, again, still big numbers. So let's solve by using the quadratic formula. Okay, so x, or not x actually, in this case we're dealing with b. So we'll say b equals a negative 200 plus or minus the square root of negative 200 squared minus 4 times a, which is 1, times c, which is 8750. All of that's going to be over 2a. Okay, so b will equal 200 plus or minus, and if you calculate everything under that square root, you'll get 5,000 all over 2. Okay, so if we split that off into the plus or minus version, we should get that b is going to equal 135.4, or b equals 64.6. Now remember, in our original equation 1, we said that a plus b would equal 200. Well, if you take a look at the two numbers we got from our quadratic formula, 135.4 and 64.6 added together is 200. So we can see that those must be the other values that work in equation 1. So we can say, therefore, the lengths of the other two sides are 64.6 and 135.4 centimeters. Okay, so when you're given a word problem, try to draw a picture. The goal is to come up with some type of quadratic equation that we can get into standard form. and factor or use the quadratic formula to find the solutions. That's all for your note for today.